Hi, welcome to Math Minute. My name is Adam, and today we're going to be talking about the first derivative test. We're going to use this to try to find maximum and minimums of functions. So this can be really helpful if we want to find a maximum population, a maximum value profit-wise. So we're going to use this, we're going to use calculus to try to get some practical applications out of it finally. So what we're going to start off with is this idea. I've drawn here a function, and I kind of briefly discussed it, I think, in one of the other videos, that the slope at a point like this is 0. So at a maximum, we know the slope is 0 because the slope's going to change from positive to negative, or you can also have a minimum because it switches from negative to positive. So what we're going to do is we're going to use this idea that the slope on this side, when it changes from plus to this side, which is minus, this has to be a max. Now the other side, if it goes from negative to positive, this has to be a min. So we're going to use that here in a little bit. So I'm going to solve a problem using the first derivative test, and I want you to come up with your own set of steps as I work along the problem. And hopefully this will help you when you try to actually solve a problem for yourself, and you'll be able to use these steps and it'll be very easy for you. So as we know, we're trying to find out when the derivative equals 0. So the first thing we need to do is find the derivative. So f prime of x equals 3x squared plus 6x. This is actually supposed to be minus 24x, so this will be minus 24. So now we want to find out when this equals 0. So let's solve this equation for 0, when it equals 0. So we can divide the whole thing by 3, which gives us minus 8 equals 0 divided by 3, which is 0. Now, from this, we need to factor it, giving us x plus 4, x minus 2. What this gives us is critical values, because when this equals 0, we know x equals negative 4, and x equals 2 will make this function equal 0. These are known, like I said, as critical values, and they're going to be very helpful here in a second. So x equals negative 4, x equals 2. So what do we know happens here? We know that the slope at this point is 0, and that has to be a max or it has to be a min. And there's one slight other case that I'll talk about in a second. So in order to do this, we want to find out if it's a max or min. So we're going to find points on each side and find if it goes from plus 0 minus or 0 minus plus for each of the points. So this is a really helpful method. We're going to use a number line. So we're going to write down our two critical values. And we want to find slopes on each side. So these three gaps, because we know it's 0 here, 0 here, and we just want to find if it's plus minus, plus minus, plus minus. We'll be able to tell from that. So down here, we're going to find slopes of tangent lines. So let's pick a point like negative 5, let's pick 0, and let's pick 3. So let's start off with 0 because we should really use that a lot. It's a good candidate, and it's really easy to solve f prime when it's 0. So if we plug 0 into this function, this is going to give us negative. 0 plus 0 minus 24. We just need to know if it's plus or minus. We don't really need to know the number. So if we plug negative 5 into this equation, again, the derivative, it's going to give us a positive. So these are all positive slopes in between. These are all negatives. And let's do 3 now. If you plug 3 into here, you're going to get another positive number. So remember, the whole goal of this is try to describe what the original function is. We're using the derivative to go back to find where max and mins occur. So as we have a positive slope right here, we know the function's increasing. So we can draw this upwards arrow. Now as it's negative through here, we can draw all downward because it has to be decreasing. Now on this side we have positive again, so we can draw that upwards arrow. So if we follow this line, we have a maximum, just from our drawing, at negative 4 and f at negative 4. And over here we have a minimum at 2, f at 2. Now I've already figured these values out, so what we can say is that we have a local maximum at negative 4, 80. Now we'll also have a local minimum at 2, negative 28. And that equals f at negative 4, and this negative 28 equals f at 2. So it kind of makes sense too to have a local max at negative 4 and 80, it's a big number, and a local min at 2, negative 28. Now there's one very special case, and it's kind of rare, and I want you to try to find a function that fits this, where we won't have this alternating plus minus forever. Sometimes when we have our number line, we could have something like plus, 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 and then it's 0 here. A 0, the derivative equals 0, and it's plus again. Well, that looks like this, a saddle point, because the value here actually is 0. It has a 0 slope, but it's positive here and positive here. So sometimes you have very rare cases where it's a saddle point. So when you're trying to maximize or minimize, you need to be very careful for this, because you could think it's actually an extreme value, but really it's not. It's a saddle point. So hopefully you came up with a set of steps that are really going to help you solve this. It's kind of a difficult concept, but hopefully you found something that works for you, and we will see you next time.